Okay, today I'm going to be showing you guys how to use Excel. We will be using Excel for our dice activity in order to help us simulate multiple random rolls without actually having to roll dice a million times. Okay, so here's what we are going to do. During this assignment, you're going to be rolling two six-sided dice that are fair. We're going to record our rolls in Excel, and the reason why we want to do that is just so it'll make it easier for us to find our probability later on. And then after we do about 10 to 20 rolls or so, we are going to use Excel to simulate a large number of rolled pairs, so like probably at least a couple hundred, if not 1,000. And then we are going to find our probability. Before we do this, we are going to want to know the expected probability. And just as a reminder, we're probably going to do this before we actually do the dice rolling. To find expected probability, we're going to want to make a tree diagram. So on a fair six-sided die like this, you have six outcomes, and all six of them have the same chance of happening. So we're going to have 6 lines here instead of 3, and then another 6 for the second one. And we want to find the probability that there's at least 1 3. And we will go ahead and do that and then record that in Excel. Okay. So why don't we hop into Excel real quick. And this is what it'll look like when you just open up a new workbook, nothing in it. What I'm going to do is I'm actually going to start by labeling 2 of the columns. We have die 1 and die 2. And this is just to help keep track of stuff. You can name it whatever you want. If you have 2 different colored dice, I have a yellow one, you can name it like yellow die and red die if you have a red one. Or whatever it is to help you more easily track your numbers. So what we're going to do is I will pull up a little simulation here just so that you guys can see what's going on. And I'm going to roll it a couple times. We got a 5 and a 6, a 4 and a 3, and a 3 and a 5. 5, 6, 4, 3, 3, 5. And if I take you back over to Excel. Okay. So the first roll was a 5 and a 6. And whenever you want to write something in a cell, you just click on it and start typing. And it'll go ahead and fill it out for you. And the last one was a 3 and a 5. And that's basically how to start writing stuff. And you're going to be doing this many, many times, just keeping track of stuff. But now I'm going to show you how to make your lives a little easier by simulating a lot of these rolls at one time. So if we do equals, that tells Excel that we are starting a function. And then we will go ahead and do rand between. And if you see this here, you can double click it. And we'll do the lowest to the highest. So the lowest number you can roll on a die is a 1. We're doing a 6-sided die, so the highest number is a 6. And then close the parentheses, and when you hit enter, it'll give you a random number between 1 and 6. And we want to do the same thing here, but something that you can do is there's this little box in the corner here. You can click and drag it, and that will basically put the same thing in this next one too. Okay, so if we want to do that for, let's say, like 100 rolls, just for now, we can drag it down to 101, because we can't count that first row, because that first row was just a label. See, it just says die 1, so it actually starts at 2. So if we put that all the way down to 101, that'll give us 100 rolls. And now we have 100 pairs of dice. Okay. So that's not the only thing we're going to be doing. We want to find the probability that we roll at least 1 3. Now you guys have, as I mentioned before, we were going to find the expected probability beforehand, and if you did that tree diagram, you should get 11 thirds as the expected, and that's just counting up however many of those outcomes has 1 3 in them on the tree diagram. So if we do equals, and we want to do equals because otherwise it'll put a date, 11 divided by, with a little slash, 36, and that'll give us our expected amount, 0.30555, repeating out of, like, is our expected probability, which is 30.5 repeating percent. And our actual, and this is where it's going to get complicated. So we need to count all of these pairs to see if die 1 is 3, die 2 is 3, or both of them are 3. So what we will do is we'll do another function. So write equals count if. So count ifs. So this is basically we're giving it multiple things to look at, whereas count if is only one. We want it to look at 2 columns, so we want to do count ifs. Okay, so the criteria range 1, if we click on the A, it'll give us that whole column. That way you don't have to, click and drag through the whole thing. I mean, you can click and drag to highlight them if you really want, but it's really going to be just faster. If you click A, that'll highlight the whole column, and that is the range that we're looking at. And the criteria is going to be what we are looking for. We are looking for 3. But that's not the only thing we're looking for. We're also looking for if this one. So another comma, click on B to do the B column, and we're looking for if that one is also 3. So that's not actually what we're like all that we're looking at, because this is only counting the ones that have both a 3 in the first column and a 3 in the second column. So what we need to do is we also need to add count if we also need to add a count ifs A is 3 and B is not 3. And we also need to add count ifs A is not. And to do not, say something is not equal to something, you do the two little greater than or less than brackets facing each other, so it makes a little diamond, and that's basically telling the Excel that it's not equal to. So we're also looking at not equal to 3, and B is equal to 3. Okay, so that's all 3 of them, and those are the only things. So we have if both of them are 3, if A is 3, or if column B is 3. Oh, okay. So if it comes up with that error, that just means that it's looking for a formula. If you put quotations around it, then it'll like actually know that it's reading a formula and not just some random number. So if we put quotations around these, like so, now it should be able to read it. There we go. So now we got 37. But 37 isn't what we're looking for. We're looking for a percent, right? So we're not done here. We also need to do divided by. Well, first, why don't we just put over here equals, we got rolls, just so we can know how many times we rolled. And to do that, we can do equals count. And this basically just does, it counts every time there is a number in one of those values. And we only have to do one of them because if we roll one die, we roll both die. So, and as you can see, we have 100 rolls, which makes sense. That's what we said. So in order to do this, so we have how many of these have a 3 in them, but we want to divide that by however many rolls we are doing. So we want to click that, and that lets it know that we want to divide by however many rolls, which is what we just found is. All right, and it looks like I actually made a mistake here. So what we want to make sure we want to do is we want to put parentheses around this whole addition that we're doing. And that just makes sure that we're adding all of these together and taking that whole thing divided by the number of rolls instead of just this last one. That's just PEMDAS. So if we hit enter, we have 0.35, which is pretty close to our results. Okay. So after we're done with this, we will be collecting data, looking at it, and talking about our actual data and the reasonability of it.